These are some places that are so dry, so untouched by the weather, that rain isn't just rare. Some years, it doesn't even happen at all. Here are 15 of the driest places on planet Earth. Number 15. The dry valleys in Antarctica. The McMurdo Dry Valley in Antarctica, it's among the driest places on Earth, and some locations within them are believed to have gone without measurable rainfall or snowfall for millions of years. It's located in southern Victoria Land just west of McMurdo Sound. These valleys are characterized by their ice-free terrain. That's a really stark contrast to the rest of Antarctica. The main valleys in this region also include the Taylor Valley, Wright Valley, and Victoria Valley. Now, the reason these valleys remain dry is due to something called katabatic winds. This is cold, dense air that descends from the polar plateau. Now, these winds evaporate any moisture in the air or on the surface before it can accumulate. The result is a hyper-arid polar desert where annual precipitation, in the form of snow, is less than 10 millimeters water equivalent, and in some areas, effectively zero. Despite the absence of rain, though, the valleys aren't completely devoid of life. Microbial ecosystems exist in the soil and in the permanently frozen lakes like Lake Friesel and Lake Vanda. These little life forms rely on the meltwater from nearby glaciers during the brief Antarctic summer rather than rainfall, and the lack of precipitation here and organic material has preserved ancient soils and geologic features, making the dry valleys a valuable site for scientific research. The ground here is rocky and barren, with scattered gravel, ice-covered lakes, and exposed bedrocks. Surface temps can vary dramatically, with extreme cold most of the year and brief warm spells in the summer that are just warm enough to cause limited glacial melt. Because of this intense dryness and the near-complete lack of weathering, some landforms and surface features have remained unchanged for tens of thousands of years. No humans permanently reside in the dry valleys, though some temporary scientific camps are set up during the summer months. The US and New Zealand operate seasonal research stations here. Access is restricted to preserve the fragile ecosystem, and all visitors have to follow strict guidelines to prevent any contamination. In essence, the McMurdo Dry Valleys represent the clearest example on Earth of a region where rain is virtually non-existent. Their extreme conditions have helped researchers better understand not only Earth's own past climate systems, but also the possibilities for life and geologic stability on other planets. Number 14. The Lut Desert in Iran. The Lut Desert, or Dashi Lut, in southern Iran is one of the hottest places on Earth. Spanning about 51,000 square kilometers, it's known for having some of the most extreme surface temperatures ever recorded. But what's less commonly known is the near-total absence of rainfall across much of the interior. Some central parts of the desert have no historical record of rainfall and show no evidence of regular precipitation in modern climate measurements. Satellite observations by NASA and surface monitoring have confirmed that the Lut Desert routinely registers temperatures exceeding 70 degrees Celsius, that's 158 degrees Fahrenheit, particularly in the Gandom-Beryan Plateau region. However, it's not just the heat that defines the region. The aridity is just as extreme. The desert lies in the rain shadow of Zagros Mountain, and it's also far from any major source of moisture. As a result, clouds rarely form and rainfall is nearly non-existent in the desert's most barren zones. The geology, too, of the desert reinforces this lack of rain. The surface is covered with dark lava rocks, sand dunes, salt flats, and what's known as yardangs, or wind-eroded ridges, all of which show little or no signs of water erosion. Soil samples and satellite imagery confirm the long-term absence of runoff or seasonal water flow in many sectors, and the plateau in particular there is so dry that even microbial life is extremely sparse. There are no permanent human settlements here in the desert, and few nomadic groups that inhabit the broader region live on its fringes, near more habitable areas where sparse groundwater is accessible. Researchers continue to study this Lut Desert to understand how landforms evolve in these hyper-arid, high-heat environments. Its conditions have been compared to those on Venus and Mars, making it a valuable testing ground for planetary science. So in short, the Lut Desert, it represents one of the clearest terrestrial examples of an environment that receives little to no rainfall in its most extreme sectors, and it underscores the impact of geography and climate patterns in creating these rainless zones on Earth. Number 13. The Eka Desert in Peru. The Eka Desert, it's part of the larger Sechura Desert in coastal southern Peru, and it includes areas that are effectively rainless. Though some peripheral zones receive limited seasonal moisture, the interior of this desert is marked by an almost complete absence of precipitation. Certain locations have no recorded rainfall in decades, and climatological patterns suggest that substantial rainfall hasn't happened for centuries. This extreme dryness is caused by the same factors affecting neighboring hyper-arid regions like the Atakama, the cold Humboldt Current, and the Andes Mountains inland. The cold current stabilizes the atmosphere above it, preventing vertical air movement and thus the development of clouds, and meanwhile the Andes acts as a physical barrier to moist air coming from the Amazon basin. This double block results in long-term atmospheric dryness across the interior. But the Eka Desert is perhaps most famous for the Paracas and Nazca cultures, which developed irrigation techniques to survive these conditions thousands of years ago. The Nazca lines, those massive geoglyphs etched into the desert surface, have survived for over 1,500 years largely because of the lack of rain and wind erosion. But modern Eka relies on irrigation canals and underground aquifers for agriculture, especially for the cultivation of grapes, asparagus, and cotton. However, these water sources are imported or drawn from ancient subsurface supplies, not from local rainfall. The hyper-arid interior is unsuitable for farming, and habitation remains largely underdeveloped. There are some meteorological stations operating in the desert's interior, and they've confirmed that annual rainfall averages are often near zero. Occasionally, a coastal fog known as garua brings in some humidity, but it rarely condenses into measurable rainfall. As a result, many stretches of the desert remain completely dry year-round with no streams, rivers, or even signs of water erosion. The Eka Desert illustrates how a combination of topographic and oceanic factors can produce a large landscape where rainfall is virtually absent. While its outer regions are more hospitable due to irrigation and human engineering, its central areas remain a near-perfect example of a land untouched by rain. Number 12. Rub al-Khali, Arabian Peninsula. The Rub al-Khali, or Empty Quarter, is the largest continuous sand desert in the world, stretching across parts of Saudi Arabia, Oman, the United Arab Emirates, and Yemen. Some interior portions of this desert have gone decades without any rainfall and are believed to have experienced such rare and negligible precipitation that it has virtually no impact on the ecosystem or even the landscape. The central areas are among the driest on Earth, with annual rainfall frequently averaging less than 2 millimeters per year, and in some years, 0. Now, these conditions are due to its position in a subtropical high-pressure belt, which suppresses any cloud formation and reduces the likelihood of any rain. In addition, the interior is far away from any ocean moisture, and no major mountain ranges nearby provide any orographic lift to generate rainfall. And as a result, the region is dominated by intense solar radiation, strong evaporation, and a persistent dry atmosphere. The lack of rain here has shaped the Rub al-Khali's landscape into huge seas of shifting dunes, some reaching over 250 meters in height. And between these dunes lie salt flats and hard pan surfaces known as sabkhas, which form in low-lying areas where the rare water that does appear, either from dew or deep subsurface aquifers, quickly evaporates, leaving behind mineral deposits. There is no surface water in the central desert, and vegetation is extremely sparse. Only hardy shrubs and isolated grasses survive near the margins, where seasonal water tables may support life. Most of the central region, however, supports no vegetation at all. Animal life is limited to migratory species or those capable of enduring long dry periods, like desert foxes and various reptiles. But the Rub al-Khali has historically been impassable to all but the most experienced Bedouin nomads. Even today, human activity is minimal. Occasional oil exploration and modern desert crossings are made with full logistics support, but there's no permanent settlements in the driest zones. While the broader Arabian Desert may receive sporadic rainfall, the core of the Rub al-Khali stands as one of the most rainless places. Its climate, terrain, and lack of biological activity all point to an environment where the rain is either absent or so rare that its occurrence has little measurable effect. Number 11. Death Valley, California. Death Valley, located in eastern California near the Nevada border, is known for being the hottest place on Earth, but also contains sections that experience near zero rainfall over multi-year spans. While Death Valley as a whole averages about 50 millimeters or 2 inches of precipitation annually, certain areas within the basin, particularly Badwater Basin and Furnace Creek, have recorded years with no measurable rainfall at all. The extreme dryness of the valley is due to a combination of factors, geographic and atmospheric. It lies in the rain shadow of four major mountain ranges: the Sierra Nevada, Argus, the Panamint, and the Black Mountains. As moist air moves east from the Pacific Ocean, it's forced upwards by each successive mountain range, cooling and losing moisture through precipitation. By the time the air reaches the Death Valley, it's dry and unable to produce any rain. The basin itself sits at 86 meters or 282 feet below sea level, making it the lowest point in North America. This unique topography intensifies any solar heating, resulting in high evaporation rates. Even when rain does fall, it quickly evaporates or is absorbed by the porous soil, often leaving no standing water. The landscape of Death Valley is defined by salt flats, gravel plains, and sand dunes, and these things called alluvial fans. Badwater Basin, for example, is a massive salt flat where rain is so rare that water pooling there evaporates within hours or maybe days. Vegetation is pretty sparse, limited to species like creosote bush, salt bush, and desert holly, which are adapted to this extreme salinity and aridity. But despite its name, Death Valley is not completely devoid of life. Several endemic species of insects, reptiles, and small mammals have adapted to survive here. Human presence, though, is limited mostly to tourism and park operations within the national park here. Historical mining operations once dotted the area, but there are no major settlements in the most arid zones. Certain years, like 1929 and 1953, saw virtually no rainfall recorded at Furnace Creek, and multi-year droughts have been documented throughout the 20th and 21st centuries. While not technically rainless in a permanent sense, parts of Death Valley come close, making them among the driest monitored locations in the Western Hemisphere. Number 10. The Atakama Desert in Chile. The Atacama Desert in northern Chile is one of the driest non-polar regions on the planet. While some parts of the Atacama receive occasional rain, certain areas, especially around the town of Yungay and the core desert zones near Antofagasta, have recorded no measurable rainfall in hundreds of years. Some studies suggest that parts of the desert may not even seen significant rainfall for as long as 500 years. This extreme dryness is caused by a combination of factors, geographic and atmospheric. It lies in the rain shadow of the Andes Mountains, which block the moist air from the east. To the west, the air currents cool along the Pacific coast, reducing the capacity for moisture in the atmosphere. And in addition, a persistent high-pressure system in the subtropical South Pacific further suppress any cloud formation and precipitation. Because of these hyper-arid conditions, the Atacama has become a significant location for scientific research. NASA has used the desert to test instruments and rovers designed for Mars, citing the surface's similarity to Martian terrain in terms of soil composition and moisture levels. Some zones of the Atacama contain such minimal biological activity that they are considered effectively sterile. That's rare even on Earth. Despite the lack of rain, though, some life has adapted. Specialized microorganisms survive in salt-rich soils, and fog harvesting plants exist along the coastal edges, where the Camanchaca fog rolls in from the sea. In recent years, innovative systems have been used to collect water from the fog to support local villages in fog net systems, and even small-scale agriculture gets supported. Human settlements in the driest areas are sparse. Cities like Antofagasta and Calama lie near the edges of the desert and rely heavily on water brought in from other regions. The desert here itself contains ghost towns that once supported mining operations, especially during the 19th century nitrate boom. Today, though, mining for copper and lithium remains active in nearby regions, but the central hyper-arid core of the Atacama remains uninhabited. While not all of the Atacama is completely rain-free, its central sector near Yungay holds the record for the longest rainless period in recorded history. It shows how geographic isolation and climate patterns can combine to create an environment where rainfall is effectively absent for centuries. Number 9. The Sahara Desert, Northern Africa. The Sahara Desert spans over 9 million square kilometers across North Africa, and it's commonly associated with extreme heat and huge sand dunes. While much of the Sahara does receive occasional rainfall, especially in its southern fringe, there are interior regions within the central Sahara that go for years or even decades without any measurable rain. Areas like the Desierto Basin in Algeria and Mali, and parts of Libya's Libyan desert have documented prolonged periods with no rainfall. The Desierto Basin, sometimes called the Land of Terror, is one of the driest places in the Sahara. It lacks any vegetation, surface water, and permanent human settlements. Rainfall here is so rare that some weather stations in the region have no recorded measurable rain for over 20 years. This arid status is maintained by the region's distance from any ocean moisture and the absence of any nearby mountain ranges to generate orographic precipitation. Similarly, the Libyan desert in northeastern Chad and western Egypt experiences some of the most extreme aridity on the planet. This region receives less than 2 millimeters of rainfall annually, and in many years none is recorded. Meteorological records from Alcufra in Libya and Dakhla in Egypt indicate years with zero rainfall, and archaeological studies suggest that some areas remained in a state of extreme dryness for thousands of years. The soil here in these hyper-arid regions of the Sahara is composed primarily of gravel, sand, and rocky plateaus. There's no evidence of recent water erosion, and natural features like dry riverbeds, called wadis, have remained unchanged for millennia. These regions lack even the sparse shrubs and grasses found in slightly wetter zones of the Sahara. But because of the extreme dryness, these parts are uninhabited, except for occasional crossings by nomadic groups or researchers. There's no agriculture or permanent infrastructure, and the survival in these zones without outside water supply is virtually impossible. However, satellite imagery and geological studies have shown that the Sahara was once much wetter, supporting ancient lake systems and even human populations during the early Holocene period. Today, though, these hyper-arid zones provide valuable data for climate science, especially in understanding how deserts expand and contract over time. They also serve as analogs for Martian environments due to their dryness and lack of any biological activity. Number 8. The Namib Desert in Namibia. The Namib Desert, located along the Atlantic coast of Namibia, is one of the oldest and driest deserts on Earth. Certain central areas of the Namib, particularly around the Namib-Naukluft National Park, have experienced decades without any measurable rainfall. While coastal fog does bring in humidity, true precipitation in the form of rain is extraordinarily rare in some parts of this desert's core. Now, the desert owes its aridity to the cold Benguela current offshore, which cools the air and inhibits any cloud formation. This condition, combined with the geographical orientation along the west coast of southern Africa, leads to extremely low rainfall totals. Some interior locations receive less than 2 millimeters annually, and even that can be highly irregular. There are documented years where no rain is recorded. Despite this, though, the Namib supports a surprising amount of life, primarily because of the thick coastal fog that rolls in from the ocean. This fog, which can penetrate over 100 kilometers inland, provides an essential moisture for plants and animals adapted to capture water from condensation. Species like the Namib desert beetle, the welwitschia plant, and fog-harvesting lichen have all evolved specifically to survive without rainfall. The central Namib region, home to iconic landscapes like the Sosuvlai salt and clay pan and the towering red dunes of Dedvlai, show little to no evidence of any modern water erosion. The dunes here, among the highest in the world, are shaped entirely by wind and not by flowing water. Riverbeds like the Shashab are dry for most of the year, only filled during rare and brief flood events originating from rainfall in the distant mountains. And human habitation in the driest parts of the Namib are pretty minimal. Indigenous groups like the Topnar people traditionally live along the riverbeds or near springs, but few people live in that hyper-arid core. Research stations, tourism lodges, and conservation outposts are the only modern facilities that exist here today. So the Namib Desert contains areas that are functionally rainless, relying instead on fog as the sole consistent source of any moisture. The combination of extreme dryness and fog-based ecosystems makes it one of the most distinctive examples of a near-rainless environment on Earth. Moving on to number 7, the Uweinat Plateau, Libya, Egypt, and the Sudan border. The Uweinat Plateau, also known as the Jebel Uat, is one of the most isolated regions in the Sahara Desert. It's situated at the intersection of southeastern Libya, southwestern Egypt, and northwestern Sudan. This granite massif rises from one of the driest expanses on the planet. This region is known for its geological stability and total environmental desolation. Large portions of it and its surrounding desert plains are thought to have never experienced rainfall in modern meteorological history. Unlike the shifting sand dunes common to many deserts, this one's composed of hard rock terrain that forms irregular plateaus and a collection of steep peaks. The area is so remote that formal weather stations don't even exist in the immediate vicinity, marking historical rainfall data pretty sparse or non-existent. However, climatological models and satellite precipitation monitoring, including data from NASA's TRMM and GPM missions, indicate that rainfall here in this region is effectively zero on an annual basis. Satellite-based rainfall accumulation maps show an average annual precipitation at pretty much 0 millimeters for many years running. The reason for it is atmospheric and geographic. Uat Uat lies deep within the Sahara at over 1,000 kilometers from the nearest coastline and well beyond the reach of any monsoon systems. It sits at the convergence of subtropical high-pressure systems that suppress any vertical cloud development. The area lacks rivers, springs, or perennial surface water, and any rare weather disturbances that do reach the nearby regions tend to dissipate before affecting the plateau itself. But despite its dryness, this area holds significant archaeological interest. In the early 20th century, explorers documented prehistoric rock art within the mountain's caves and shelters. These petroglyphs, estimated to be over 8,000 years old, depict giraffes, ostriches, and human figures, evidence that the region once supported life during a much wetter period, known as the African Humid Period. This art offers critical proof that the climate has changed drastically. The complete lack of current vegetation further supports the absence of this rainfall. No desert shrubs, succulents, or grasses survive here, and the surrounding plains are dominated by loose sand, dry lake beds or playas, and fossilized dunes. The geology here is also what shaped its extreme dryness. The wind erosion, rather than water, is the primary sculpting force. The granite surfaces are worn smooth by constant sandblasting, not rainfall runoff, and soil development is minimal or absent, and the few wadis, the dry channels found in the region, have not carried water for thousands of years. Access to the area is extremely difficult. There's no roads, towns, or support infrastructure within hundreds of kilometers, and expeditions into the region have to be entirely self-sufficient, bringing all your supplies, including large quantities of water, fuel, and communications gear. Most visitors today, though, are geologists, archaeologists, or adventure researchers retracing the routes of early 20th century desert explorers. And the Egyptian and Libyan governments do restrict access to parts of the plateau due to its border proximity and some sensitive archaeological significance. There's no surface reflectivity here either, indicating any wetness, no signs of vegetation cover, no signs of cloud cover in most multi-year composite images. Dust storms and sand flows are occasionally visible, but rain-related erosion features like alluvial fans or stream channels are entirely absent from the interior plateau. And despite being a site of no rainfall in recorded memory, Uat Uat retains a deep connection to ancient climate cycles. The presence of rock art and extinct lake basins in surrounding areas are reminders that extreme aridity is not necessarily a permanent state, but it can result from gradual shifts in the Earth's orbital patterns, solar insolation, and regional monsoon dynamics. Yet for the past several thousand years, and for the foreseeable future, Uat Uat remains locked in a regime of absolute dryness. Number 6. Arica, Chile. Alright, we're back in Chile. Arica, a coastal city in northern Chile near the border with Peru, is often cited as the driest inhabited place on Earth. It lies within the Atakama Desert, and between the years 1903 and 1918, the city recorded an average annual rainfall of just 0.76 millimeters. Some years saw absolutely no measurable rain, and even today, Arica's annual rainfall is generally less than a millimeter, and several stretches of multiple years without any have been documented. Now, that aridity is due to the influence of the Humboldt Current and the city's location in the coastal desert zone. This cold ocean current cools the air, preventing any moisture from rising and forming any rain clouds. Additionally, the Andes Mountains to the east block moisture from the Amazon Basin, creating a double rain shadow effect. As a result, the atmosphere above Arica is stable and dry, with very little vertical air movement that could generate precipitation. But despite the lack of rain, Arica is a functioning city with over 200,000 people. Water is supplied through a combination of aquifers, rivers originated from the Andes, and desalination. The city has adapted its infrastructure to account for this lack of rainfall, and traditional agriculture in the nearby valleys uses irrigation rather than relying on natural rain. The Dry climate here also contributes to the preservation of archaeological artifacts. The Chinchorro mummies discovered in the region are some of the oldest artificially mummified human remains in the world. They were preserved for thousands of years in large part due to the hyper-arid conditions. While fog, known as Camanchaca, occasionally rolls in from the ocean, it doesn't produce any rainfall. Some native plants and animals have adapted to harvest the moisture from the fog, but measurable precipitation is effectively absent. Buildings in Arica often don't have any rain gutters, and storm drains are unnecessary in most parts of the city. The climate's also made it a hub for solar energy research and desert studies. The consistent sunshine and lack of rainfall offer ideal conditions for long-term outdoor experiments and equipment testing. Arica is a rare example of a modern city functioning in an environment with nearly zero rain. Its adaptation to water scarcity and unique climate make it one of the most extreme yet livable dry zones in the world. Number 5. Iquique, Chile. Alright, we're keeping it in Chile. Located along Chile's northern coast, Iquique is another city in the Atakama Desert that receives almost no rain, much like nearby Arica. Although Iquique is slightly wetter on average, some parts of the city and its surrounding desert have recorded zero rain for years at a time. This city lies within one of the driest regions on Earth, where annual rainfall often measures less than a millimeter. The main reasons for this, of course, are oceanic and geographic. Iquique sits next to the Humboldt Current, that's a cold ocean stream that cools the air and prevents it from rising to form clouds. The result is a consistent temperature range and virtually no rain, despite the city's proximity to the Pacific. Despite that lack of precipitation, Iquique is a major urban center with a population of over 200,000. Water is delivered through aqueducts from more distant Andean sources, and in some cases through desalination. Agriculture in the region is limited and only possible in isolated valleys or using imported water. Their infrastructure isn't built with rainfall in mind. Roofs typically lack drainage systems, and roads aren't equipped with stormwater systems. Iquique also has a long history as a port and mining hub. In the 19th century, the surrounding desert was a source of valuable nitrate deposits, and the city played a central role in the saltpeter boom. These mining towns were often built in the surrounding desert, where rain was so rare that many structures never experienced a rainstorm during their entire use. The dryness of the environment here also contributes to the preservation of historical artifacts. Many abandoned nitrate towns remained remarkably intact due to the lack of decay from any rain or moisture. In modern times, the arid climate has made Iquique an attractive location for astronomical research and testing of solar energy equipment. Iquique is another example of a functioning city in an area where rain is so rare that it plays virtually no role in everyday life. Its adaptation to the extreme dryness through infrastructure and water management makes it one of the driest inhabited regions on Earth. Number 4. The Alcufra Basin in Libya. The Alcufra Basin, located in southeastern Libya, is one of the driest regions in the Sahara, and indeed the world. It's centered around the town of Al Jauf in the Kufra district. The basin is situated deep in the Libyan desert, an area so dry that many weather stations in the region haven't recorded years, sometimes decades, without any measurable rainfall. This hyper-aridity is the result of several geographic and climatic factors. The basin lies far from any significant source of ocean moisture, and it's shielded by mountains and plateaus that prevent the incursion of any rain-bearing clouds. As a result, the Alcufra Basin is characterized by clear skies, high daytime temps, and low humidity nearly every day of the year. Despite the extreme climate, though, there is a small population that's historically relied on underground water here, particularly the Nubian sandstone aquifer system. This ancient system is one of the largest in the world, and it provides groundwater that supports small-scale agriculture and drinking water through deep well systems and artificial oases. However, the rate of extraction far exceeds the aquifer's natural recharge rate, and its sustainability remains in question. The region became more widely known in the mid-20th century due to development of Libya's Great Man-Made River Project. That was a massive pipeline system designed to transport water from deep underground aquifers to coastal cities. Some of the well fields are located near the Alcufra Basin and play a vital role in this ambitious water supply scheme. The desert surrounding Al Jauf is largely uninhabited and marked by flat gravel plains, rocky outcrops, and sand dunes. There's no rivers or lakes in the region, and even seasonal water courses are absent. Vegetation is extremely sparse too, limited to a few drought-resistant shrubs or isolated palms in irrigated plots. Rainfall data suggests that some locations in the basin haven't seen a recorded rain event for over 20 years, and satellite observations also indicate that the land has remained unchanged by water erosion for long periods. The Alcufra Basin. It stands out as one of the driest settled regions on Earth. While life continues in the town due to deep groundwater extraction, the broader area remains an example of how people have adapted to an environment where rainfall is effectively non-existent. Number 3. Luxor region, Egypt. The Luxor region in southern Egypt is world-renowned for its ancient ruins and proximity to the Nile River. It also borders one of the most arid zones on the planet, the Eastern Sahara. While Luxor itself receives a marginal amount of rain, often just a few millimeters a year, the vast surrounding desert, particularly the terrain east and southeast of the city, includes large tracts of land where rainfall is virtually non-existent. This hyper-arid region represents an environment so dry that rain, if it happens at all, plays no role in shaping the landscape, the vegetation, or even human activity. Now, the extreme dryness is a result of its location and the prevailing atmospheric conditions. The region lies deep within the subtropical high-pressure belt, where descending air masses inhibit any cloud formation and just suppress rainfall. Combined with the inland position and the presence of barriers like the Red Sea Hills, the region is effectively cut off from moisture-bearing wind. As a result, the skies remain almost perpetually clear and the land is scorched by high solar radiation throughout the year. But the land east transitioned from the irrigated Nile Valley into barren rocky plateaus and sandy plains. This is part of the Eastern Desert, a geologically diverse expanse of terrain that stretches all the way to the Red Sea. The surface consists of ancient rock formations, dry wadis or seasonal riverbeds, and gravel-covered plains. Some of these wadis, such as Wadi Hammamat, were once routes used by ancient Egyptians to transport goods, but they're now entirely dry and barren. Even areas with scientific outposts such as the Gif Kabir Plateau to the southwest report zero annual precipitation, and they've done it for consecutive years. But despite the climate, the Eastern Desert holds a rich archaeological legacy. It was traveled by quarrying expeditions in ancient times, who sourced rare stones like porphyry and basalt used in temples and monuments across Egypt. Without rain to erode or disturb any sites, many ancient inscriptions and cartouches carved into cliff faces have remained almost perfectly preserved. These inscriptions offer critical insights into the lives of the workers and the expeditions who journeyed into the desert millennia ago, enduring the same relentless sun and dryness that defines the area today. The lack of rain also affects the infrastructure. Roads traveling the desert are few and often in poor condition, and there's no need for storm drainage systems or protection against flood damage. Buildings, when they exist, are constructed to withstand extreme heat and dust, not rain, and as a result, maintenance is focused on insulation and air filtration, not weatherproofing. The environmental conditions in the Eastern Sahara have made it a prime location for scientific research, especially studies concerning climate change, desertification, and planetary analogs. Several expeditions have used the desert to test equipment for Mars exploration. The European Space Agency, among others, has used parts of it for robotics and sensor experiments in preparation for missions to arid planetary surfaces. Unlike deserts that occasionally bloom after rain like those in Chile or Australia, the Eastern Sahara shows no signs of temporary greenery or water accumulation. The land remains constant with sharp rock outcrops and endless plains of dust and gravel. These conditions also make the region ideal for solar energy development. Several proposals have been made to build large-scale solar farms in the region, although few have progressed due to logistical challenges and, of course, the remote location. From a climatological standpoint, the near-total absence of rain does contribute to some large diurnal temperature shifts. Days can reach over 45 degrees Celsius in the summer, while nights may drop to 10 degrees Celsius or lower. The lack of humidity also intensifies the feeling of heat during the day and cold at night. Air quality is dominated by dust, which is frequently blown into the Nile Valley and even further across northern Africa. Despite all the harshness, though, the region does hold some natural beauty in its formations. Sandstone cliffs, narrow gorges, and ancient rock pavements that bear the footprints of ancient humans and animals. Some researchers believe that early humans migrated through this region during prehistoric humid periods, evidenced by cave art and fossilized remains. These remnants offer an amazing contrast to the current dryness, providing some clues to climatic shifts over tens of thousands of years. In more recent times, though, Egypt has considered using parts of this desert for strategic development projects. One of the proposals includes extending transport routes from Luxor to the Red Sea coast to facilitate trade and tourism. The plans often require substantial investment in water and energy infrastructure, and due to complete absence of natural water sources, nevertheless, the desert's location between major population centers like Luxor and Hurghada makes it a candidate for future development. The region east of Luxor is one of the most arid environments on Earth. It's a place where rain is so rare that it shapes every aspect of life and landscape. The Eastern Sahara is a vivid reminder of how geography dictates our human adaptation and how entire regions can function without ever feeling the impact of rain. The scientific value too, historical significance, and environmental uniqueness make it an enduring subject of fascination for researchers and explorers alike. Number 2. Gran Desierto de Altar, Northern Mexico. The Gran Desierto de Altar, or the Great Altar Desert, is one of the most extreme deserts in Northern America. It's located in the northwest corner of the Mexican state of Sonora. This expanse of sand dunes, barren plains, and cracked clay surface forms the western section of the Sonoran Desert. Now, what sets it apart from other arid environments is the presence of large interior zones that are so dry they've gone years, and in some isolated patches, decades without a single measurable rainfall event. These areas aren't just dry by comparison, they're effectively rainless. The desert covers about 5,700 square kilometers, and it borders the Gulf of California to the south and the U.S. border near Arizona to the north. Its central zone contains the largest active dune field in North America, with dunes that rise over 200 meters in some area. The climate here is shaped by a combination of high-pressure systems, oceanic influence, and regional topography. While peripheral areas near mountain ranges may experience occasional storms, the heart of the Gran Desierto receives almost nothing. Meteorological records from nearby stations indicate annual precipitation levels as low as 25 millimeters, with some years just registering 0. However, those stations lie on the fringes of the desert. Within those interior dune fields, no official weather station operates, and satellite-based precipitation estimates show that some zones have likely gone more than 20 years without rain. The Yuma Desert to the north acts as a transitional zone between the Sonoran Desert and the Mojave, but the Altar Desert is more isolated and lies in a basin surrounded by low coastal ranges and extensive dune fields. That creates localized rain shadow effect where little moisture in passing air masses is unable to condense and fall. Vegetation here is sparse to non-existent in the central dunes. Where it exists, it's typically limited to drought-resistant species like creosote bush, octilio, and ironwood trees, but these appear mostly along the margins or isolated pockets near groundwater. In the dune core, the shifting sands are devoid of life. Studies conducted by biologists in the 1990s and 2000s recorded areas where no visible plant life existed across several square kilometers. These sterile zones show no evidence of any recent biological activities, and that's consistent with an absence of water. Despite the aridity, though, it forms part of the larger Biosphere Reserve, which includes volcanic craters, lava flows, and shield volcanoes, such as El Elegante. While the dunes are lifeless, the surrounding volcanic terrain supports species like desert bighorn sheep and the Sonoran pronghorn, which survive by relying on underground aquifers and dew. Human activity in the desert is almost non-existent. Historically, indigenous groups such as the Tohono O'odham lived in the desert's fringes but never ventured deep into the dune sea. Modern settlements remain outside the central region due to the inaccessibility and lack of water. Roads, power lines, and communication infrastructure stop short of entering the desert's core. Military and environmental organizations have occasionally conducted overflights and brief land expeditions, but permanent stations don't exist. The central dunes here show no signs of any water erosion, only what's known as aeolian or wind-driven shaping. The dry lakebeds or playas remain unfilled year after year, with their surfaces crusted by salt and baked clay. And even after rare thunderstorms skirt the desert's edge, no runoff or pooling reaches the interior, and evaporation removes any surface moisture within hours. Now, from a scientific standpoint, the Gran Desierto is of interest for studies in desertification, geomorphology, and climate modeling. The Mexican National Commission for Natural Protected Areas and international research institutions have used the region to test theories about dune migration, atmospheric moisture limits, and soil chemistry in these arid environments. The absence of any rainfall does provide a control environment where other variables like wind, solar exposure, and temperature can be studied without the confounding influence of water. The Landsat program, MODIS data, and commercial satellite providers have all documented the lack of vegetation and hydrological change. No river systems penetrate the desert, there's no evidence of recent water flow across the region, and infrared sensors show consistently high surface temps and reflectivity consistent with these dry sand and bare rock environments. Climate projections will remain rainless for the foreseeable future. If anything, climate change may intensify the aridity, but models predict increased temperatures and decreased regional precipitation, meaning the interior zones could become even more sterile and lifeless over the coming decades. And this has implications for surrounding communities, which may see their already limited water resources strained even further. In terms of planetary science, some researchers have compared it to the dune fields of Mars, both in texture and dryness. This lack of moisture, minimal biological contamination, and the long-term preservation of wind-shaped features make it a terrestrial analog for dry extraterrestrial landscapes. Robotic sensor tests and remote sensing calibration tools have been field-tested here, especially in preparation for Mars surface missions. Despite being inhospitable, though, the Gran Desierto de Alta remains legally protected as part of Mexico's UNESCO-designated biosphere reserve. This status ensures that mining, construction, and motorized access is strictly limited, preserving the pristine condition of one of Earth's driest and most unusual places. Number 1. The Taklamakan Desert in China. The Taklamakan Desert, located in the Tarim Basin of northwestern China, is one of the largest sandy deserts in the world, and it's one of the driest regions on the planet. Within these huge shifting dune fields, some of which are over 300 meters high, lie areas that are so remote and so isolated from weather systems that they have no recorded instances of rainfall. Certain basins within the interior are so arid and so enclosed that they may have gone centuries without a single drop. Now, this area is bordered by two major mountain ranges, the Kunlun Mountains to the south and the Tian Shan Mountains to the north. These high ridges block nearly all incoming moist air mass, creating a strong rain shadow effect. As a result, the central basin is deprived of any meaningful moisture from monsoons, cyclones, or even westerly systems. Temperatures in summer can exceed 40 degrees Celsius, that's 104 Fahrenheit, while winter temps can plunge well below freezing. But regardless of season, rain is effectively absent here. Now, what makes it unique is the scale and the inaccessibility. It spans over 337,000 square kilometers, and it's almost entirely uninhabited, except for scattered settlements on the outer rim, primarily along the ancient Silk Road routes. The sand dunes here shift frequently due to strong wind, and any water that does exist in the atmosphere just evaporates before it reaches the surface. Now, one of the most significant pieces of evidence for the lack of rainfall here is the preservation of ancient ruins buried in the sands. Several centuries-old settlements and tombs have been found almost perfectly preserved due to the absence of any moisture. For example, the Lulan Kingdom, once located on the desert's fringe, was buried and fossilized by sand after the local lake system dried up. Archaeologists have noted that organic materials like textiles and wooden structures remain intact for centuries because they've never been exposed to rain or humidity. And modern infrastructure projects in the region like the Tarim Desert Highway cross parts of the desert that have no recorded rainfall. Engineers have to regularly clear the sand drifts from the roads, but they don't build a drainage system because there's no rain to drain. Even China's vast meteorological station network has sparse data points here due to the challenges of maintaining instruments here. Climate scientists study the Taklamakan because the region provides valuable data on how deserts expand and contract over thousands of years, and how extreme dryness alters soil chemistry, biodiversity, and erosion patterns. But despite the reputation as a dead zone, the Taklamakan has not been entirely devoid of human influence. Oil and natural gas exploration have brought the roads and equipment to the outer reaches of the basin. A few scientific outposts operate temporarily there, and their presence is dictated by short-term field work, and all personnel have to bring extensive supplies. In terms of that precipitation measurement, nearby weather stations on the edge of the desert, like those at Hotan and Korla, report extremely low rainfall, often less than 20 millimeters a year. But as one moves inwards, satellite-based sensors show that the rainfall trend approaches zero. In fact, a 2006 study using MODIS satellite data found that the Central Basin likely had areas with zero recorded precipitation for well over 20 years. No vegetation exists in these zones, and ground temp sensors show no thermal anomalies that would suggest evaporating cooling from water presence. So the Taklamakan Desert's deep interior qualifies as one of the most rainless places on Earth. It's shielded by mountains, it's starved of moisture, and it's dominated by moving sand. The central basin has remained untouched by rain for decades, possibly even centuries. It stands as one of the most definitive examples of a land where rainfall simply does not happen.